Hello everyone, my name is Vaishnavi Verma. My roll number is 205068 and my topic name is linear transformation. First I will discuss about some basic fundamentals. The first one is the mapping. Mapping F from set A to set B is a relation that associated with each element of A of a set A to unique element of B in B. It is denoted by F such that A relation to B. If A belongs to capital A, then F of A is equal to B, that B is belonging to set B. F of A is known as image of A and A is known as pre-image of B, that B is equal to F of A. Now the second one is well-defined mapping. A mapping F such that A belongs to B is said to be the well-defined if every element of A has image in B and but not necessary element of B has pre-image in A. The second one is every element of A has a unique image in B. Two or more than two elements of A can have same image in B. Now the third one is one-one mapping. A mapping of F such that A belongs to B is said to be the one-one if every element of A has separated element image of B. Let A comma B belongs to A such that F of A is equal to F of B. That means image of F of A is A and the F of B image is B. That means A is equal to B. Or we can write that let A comma B belongs to capital A such that F of A does not equal to F of B. That means image of A does not equal to B. Now come to the fourth point, many one. A mapping F such that A belongs to B is said to be the many one if at least two element of A has same image in B. Now the fifth one is onto mapping. That means set A, the relation given F, the set B. For all the element of X belongs to B set B, then there exists Y belongs to A, that means set A, such that image of F of Y is equal to X. A mapping if F such that A belongs to B is said to be the onto if every element of B must have pre-image in B. Now the sixth one is into mapping. A mapping F such that A belongs to B is said to be onto into if at every element of one element of B does not have pre-image in B. Now the next topic is linear transformation. If if V, that means vector space, and W is the subspace, are two vector space over the same field F, then a mapping T such that V belongs to W is said to be the linear transformation. If satisfy this property, then we can say this is a linear transformation. T C alpha plus beta is equal to C T alpha plus T beta for all alpha comma beta belongings to V and C is belonging to F. F is the field and V is the vector space. Now we taking the first example so that the mapping T such that R square to R defined as T x1 comma x2 is equal to x1 minus x2 comma 0 is linear transformation. Now let alpha and beta belongs to R square and C is belonging to field. Alpha is the vector space that we can take magnitude a1 and a2, and beta has magnitude b1 and b2. And C alpha plus beta we can write in this way: ca1 plus b1 comma ca2 plus b2, that also belongs to r square. Now t c alpha plus beta, t ca1 plus b1 comma ca2 plus b2, ca1 plus b1 minus ca2 minus b2 comma 0. Next step, ca1 minus a2 plus b1 minus b2 comma 0, ca1 minus a2 comma 0 plus b1 minus b2 comma 0. T c alpha plus beta is equal to c t a1 comma a2 plus t b1 comma b2. T c alpha plus beta is equal to c t alpha plus t beta. Hence T is a linear transformation. Now the next one is, so that the zero vector, matlab that means transformation from vector space to vector space W is a linear transformation. So we know that zero vector is the transformation from theta such that V is belongings to W is defined as del alpha is equal to 0 for all we have to, so that S is a linear transformation. Let alpha comma beta belongings to V and C belongings to F. C alpha plus beta is also belonging to V. Now del C alpha plus beta is equal to the 0 vector, so 0 plus 0 is also 0, and C 0 plus 0, del C alpha plus beta is equal to C alpha del alpha plus del beta. Hence S vector is a linear transformation. Now the next one is, so that identity transformation on the vector space is linear transformation. We know that identity transformation on V is denoted by I, given as I is such that V tends to V, and defined as I alpha is equal to alpha for all alpha belongs to V. So that I is a linear transformation. Let alpha and beta belongings to V and C belongings to F. C alpha plus beta, the C alpha plus beta belongs to V, and I C alpha plus beta is equal to the C alpha plus beta and C I alpha plus I beta. So hence I is the linear transformation. Now the discuss about the some properties of linear transformations. The first one is T0 is equal to 0, T alpha minus beta is equal to the T alpha is equal to T beta. So third one is the T C1 alpha 1 plus C2 alpha 2, so on Cn plus Cn multiply में alpha n, so on. These are the properties of linear transformation, and thank you.